Yeah, good evening, everyone. Which one I can? Let's start off. This was the last thing that we did. Let's see one more like this. We have a block of mass M. We have a rubber band K, L. Initially, the system is at rest. Gravity is there. So block is pulled down by A and released. Find time period. Others, do keep your cams on. This is a rubber band, huh? You know the difference between a rubber band and a spring, right? If you try to compress a rubber band, it will just become useless. If you stretch a rubber band, it is as good as a spring. But the moment you try to compress a rubber band, it is useless. How do you do this? Try. It's a good one. This and the last problem we did, last one is a pretty good one. I hope you have gone this and tried this again on your own. How do we do this? I put m by k to a y. Interesting. You guys are going up. Wrong, wrong. All answers are wrong. I'll give you a hint. See, you're mistaking something. Natural length of the rubber band is not the same as the initial position of the rubber band. I hope you have taken that into account. Same thing happened in the last problem also. You guys did the same mistake. You guys thought the natural length of the spring was the mean position. Initially, this is mean position. Mean position is not the natural length of the rubber band. Think, think, think. Take a minute. I'll show you. It's a worthy problem. Show you. See, again, like I always keep saying, if you can draw the final diagram, this, is the biggest difference, between you guys and old timers like me. When we used to solve, right, we never had enough material, okay? We had only like HC Verma and Maximum Merido. इसके ऊपर कुछ books ही नहीं था. So we have to solve the same book multiple times. So we literally, right, used to spend more time, somewhere down the line, right? You guys think that you have to solve a lot of questions. And there's a competition also, ना? Your friend will come and say, मैंने Cengage कर लिया, मैंने वो कर लिया, ये कर लिया. तो अभी आपको भी लगता है यार, मुझे भी सब करना है. Instead of going in depth into the problem, figuring out what is happening, what is not happening, you guys keep, struggling with that. So the analysis part is missing. How many of you actually figured out the diagram properly? So initially you pulled it out. This was the natural length. This was the mean position. This is the point you released it from. So there are actually three different points here. And what is this length here? Since it is an equilibrium, k into x is equal to mg. So this guy was mg by k. And this thing you pulled by a. Make sense? Now when you release from here, what happens? The block will come to mean position. Will it come to rest? No, it will go with maximum speed. So from here to here, how much time will it take? T by 4, where time t is nothing but 2 pi root over m by k. Because if you leave from this position, this is nothing but your extreme position. Why it is extreme? Speed is 0 now. During the motion, any point with a 0 speed is your extreme position. That is t by 4. Then this guy will come to the natural length. Remember, spring is still pulling you. Rubber band will stop acting once you try to compress it. Isn't that the word? What do you mean by compress it? Length should be less than natural length. That means the rubber band will keep pulling you till it reaches the natural length. Maybe I'll remove the arrows here. At this point, rubber band becomes slack. Now from here to here, let the time be small t, which I don't know. After this point, what will happen? Now this guy will have a speed here. Let's call it some v, which I can find actually. V is nothing but omega into root over a square minus x square. This x is mg by k. That is your speed there. At this point, what will happen? The rubber band will become slack. And this guy is flying like a projectile motion. So this behaves like projectile. So from here to here, it will be time of ascent, which is nothing but v by g. So the total time taken will be, so time period will be the t by 4, pi by 2, root over m by k plus t plus v by g 2 times. There are 3 parts for the problem. But remember, abhi tak small t humne nikala nahi. How to find small t? We know
I didn't include
x,
time of ascent.
which one?
Time of ascent क्यों include कर?
Time of ascent.
क्यों include कर?
What is the definition of time period? So you mean to say at this point what will happen? The block will just come to rest and go back. When the block reaches the natural length, what will happen? Will the block come to rest?
No.
Block will not come to rest. Block will have some velocity. So after that point, जब rubber band lose हो जाएगा, there are what are forces acting on the block? Only mg. There is no spring force. It just behaves like a regular projectile. It feels as if it's got thrown into the air. And this guy will be mg by ak is sine omega t. This is where you get the time from. 1 by omega sine inverse mg by ak. Is this making sense?
So at Vmax, mg is equal to m omega square x, right?
Vmax will be a omega.
No, over there mg is equal to m omega square x, right?
mg is equal to
Then that force has to be
omega.
0
कहाँ पे है?
at the mean position. You define.
हाँ, so that's how I got this thing, mg by k. Kx is equal to mg.
हाँ, ठीक है.
At the mean position, the spring force kx will be equal to mg. So that is how I got that mg by k from there. Is this clear, everyone? So before jumping into the problem, forget about solving the problem also. This is what you should have figured out. If you have done this, you have done the physics part right. Then comes solving and all. That's the second part of the problem. Most of you guys are more bothered about the equations and solving. You're not realizing what is happening with the problem. And because of that, what is happening, right? You're not able to think of all possibilities that can happen. So always, focus on that. What is happening with the problem? How does the block look like? What will happen after this? What will happen after this? I keep asking, what happens after this? And finally, what happens? After this, finally, what happens? This block will again come down. Again, the string will become tight. Again, it will stretch. Again, it will come back. And this will keep on happening, isn't it? The motion will just keep repeating forever. So if you have actually realized this, you will realize there are 3 parts in the answer, isn't it? And in the exam, you will find at least 2 options with only 2 parts. You could eliminate them. There's no need to solve the question also, trust me. Maximum times you'll be able to get the answer.
No, omega like पूरा time period से calculate करेंगे, right?
Omega is the time period when it is in SHM, right? Is this block in SHM? Is this SHM, everyone?
So that we'll have to differentiate and find out.
This is this is only SHM from here to here. Uske baad, it is something else. It's a periodic motion. This is not an SHM motion. This is a part SHM and part periodic, isn't it? So the overall is periodic. Once the rubber band becomes loose, it is not an SHM anymore. For example, this question when I asked you, do you think this is SHM? This is not SHM. This is a part of an SHM. Till here to here, this is a part of an SHM. You're missing this part of the motion. What is SHM definition? Then net force should be always towards the mean position and proportional to x. But during collision here, this force will be an impulsive force, isn't it? And that is not proportional to x. This is not SHM. It is a part of an SHM. Arjun? Make sense?
Yeah.
These are especially good ones, gods. You should try this again. Clear?
So, but sir, if they ask us for omega, what do we write in the answer?
Just think K by M. This thing, end of the day, is still behaving like a spring block, right?
So we won't write the whole time period.
So you're asking omega of the full system, you're asking?
Like, yeah, for
If you
like
are,
one complete
then it will be 2 pi by this whole guy.
Okay, fine. Understood. Thank you.
If you're asking that way, for the whole motion, तो वो अलग है.
Yeah,
But they won't ask you that. If the whole motion, if I want to ask you, I'll ask you F, the number of oscillations per second.
okay.
That would make more sense than asking omega. Clear with this? Let's do a little easy one, then we'll go for a deadly one. We have a spring block system. This guy is oscillating with an amplitude A. X is equal to 0. This is your mean position and natural length also, because कोई है ही नहीं horizontal forces. Block M oscillates with amplitude A. Then what it did, another block of mass M is stuck on top of it. Case 1, at mean position. Case 2, at extreme. Meaning, so when the block is moving here, you took another block M here and you placed on top of it. You got it stuck at the mean position. And remember, mean position, your speed is maximum. Second scenario, when the block is here at x is equal to A, then you took another block M and you made it stuck. In both the cases, find the new time period and the new amplitude. Yep. हाँ पलक. Clear, na? When you get stuck, meaning E is 0 basically. What will happen to the new time period and the new amplitude? The time period is the easiest one. See, case one. When the block is at the mean position, your speed is Vmax, which is A into omega. The moment you put one more block on top of it, remember, net force is 0 here because it's at mean position. Therefore, momentum is conserved. So this guy ka speed will become V by 2. M into V is equal to 2M into V dash. So V dash will be V by 2. The speed becomes half. The time period is simply 2 pi root over M by K. M became 2M by K. Isn't it? Because how do you find time period anytime? You stop the body, bring it to equilibrium, displace it. The story to wahi hai. So who cares how much is it oscillating with? 2 pi root over 2 pi M by K. Right? And what about the amplitude? Now from here, when this block goes forward, I can use energy or I can do this. So this is your new maximum speed. So this is your time period. So omega nu will be root over K by 2M. This is your new time period. The new maximum speed is also V by 2, which is A omega by 2. This is also equal to A nu by omega nu. So A omega by 2 is the new amplitude into this thing root over K by 2M. This is A by 2 and omega, the old one is root K by M. I can use energy conservation also after sticking and I can get this. A nu is A by root 2. Check. This is one way to do. Or you could have done this also. This block won't stop here. It will continue to go further and finally stop here. This would be in your new amplitude. So you could have written half 2m v by 2 whole square is equal to half k a nu square. That also would work. Conserve energy after sticking, not before and after. Because when you're sticking E is 0, you lose energy. Or we can use this formula. The new speed which you get is your new maximum speed. Because that is still the mean position. Clear? Please have a look at this. So either you can use energy part or you can use this V is equal to A omega and get this. What about the second part? Case 2, This is your mean position. This is block M. Now see, the speed is already 0. You can put it in the total mechanical energy formula. You can do that. Meaning, what is the total mechanical energy? Half the new mass, new amplitude into omega square, na? You'll get it. I hope you remember the formula. Energy is half from omega square a square. So ये m हो जाएगा 2m. Omega will become omega nu. A will become a nu. And energy becomes how much? Half 2m v by 2 whole square, isn't it? You should do that. And you'll get the same thing. End of the day to वही कर लिया. You made Vmax is equal to a omega by 2. So here, if you see, F net is not 0 because there is a spring force. Right? So linear momentum is not conserved. But since V is 0, there's no loss of energy. This is A. So when you stick another block M here, this is still A. And this velocity is still 0. Isn't that the definition of an extreme position? During the motion, the point with 0 velocity is the extreme position. Which is still amplitude. But chalo, freebie, if you think we have to solve, so let's say after some time, the block will come to this side. Let this be A dash. So this is also V0. You can conserve energy. Half K A square, kinetic energy is 0, is equal to half K A dash square. A dash is equal to A. So simple reason, since there's no loss of energy, amplitude will not change. And what is the new time period? 2 pi root over 2m by k. It is still the same. Time period is the most easiest thing. I don't care what is happening. I'll simply write 2 pi root over total mass by k. So in this case, momentum is conserved, but energy is not conserved. That's why the amplitude got messed up. In this case, momentum is not conserved, energy is conserved. You might think then, sir, what is the difference exactly? The difference here is when it comes to the mean position, it won't come with the same maximum speed. Speed will decrease. It will have a lesser maximum speed. Please check it out. I hope you're getting why energy is conserved and not conserved in one situation. Clear?
So why isn't energy conserved in the first situation?
You tell me. What is the block का speed?
Was V pehle and then you kept that, so V by 2.
You kept another block. एक block का speed कितना था? The one which is oscillating, उसका speed कितना था?
V.
A omega or V max. What is the speed of the second block? 0. If you make two blocks tick like this suddenly, won't they skid for some time? And if they're getting stuck, that means there's a relative motion. If there's a relative motion, there is a friction. And if there's a friction and if they're skidding, you lose energy. It's basically a perfectly inelastic collision. Why is there no problem here? Because initially, what is the velocity of the block? 0. What is the velocity of the block you're keeping? 0. There's no relative velocity. There's no friction, is static. So there's no loss of energy. This thing is behaving like, bullet getting stuck to a block problem, na? Clear, everyone? Getting why is energy not conserved there? Anyone else not convinced with this? Please ask me. It's not a tough one, but it's a very good one. It's a standard problem. This is a proper mains or bits level problem. Great. Next one. We have 4 rods here, 4 massless rods. It's a rhombus. Length L, 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 L. This is theta. This is theta. And then you connected a spring in between them. Okay. This is hinged here. Basically, this thing can compress. And at the bottom here, you have a mass M. So we have a rhombus here made of light rods. So rods don't have mass. With a spring connected as shown. So the spring is connected here and here. Now the block is slightly pulled. It is gently pulled. The block is displaced slightly. That word is important, meaning you're not displacing it too much that the angle changes. Displaced slightly. Displaced vertically by a small x and released. Find the time period of oscillation. Just to give you a little context, this is how the thing would have looked. The moment you pulled it down, this would have become like this. Are you able to visualize how it is? So basically, this displacement is x. You're getting? So when you pull it, the rhombus will compress, na? The rods all are compressed, meaning you have hinges here. These are flexible hinges. Is the scenario clear? Are you able to visualize, na? How is that thing? So when you press, the ring will try to, the spring will in the middle will resist you. So if I pull the block here, the spring will compress. Hope that is fine. If the spring is compressed, what will it do? It will push you back. The block will come up again. The block will go down again. This will keep on happening. Find the time period. The half angle is theta. Anyone who didn't get the diagram, please ask me. Diagram is clear. Go ahead. You got 2 to 3 minutes. Think for a minute, then I'll tell you something. Then I'll give you another minute or two. Think whatever you think. How the hell to do this problem? Now, let me tell you something. Let's start like this. Let's say I pull this by x. If I pull this by x, do you think spring will compress by x?
No.
Spring कुछ compress होगा some y. Find that y. Start from there. So indirectly, you know what I'm asking? You have a rhombus. So I'm asking, if I increase the length of this rhombus by x plus dx in the vertical direction, the horizontal will become y minus dy. Agreed? What is the change in horizontal length? So by pulling the rhombus vertically, you're shrinking it. It is becoming little flattish in the center. Start from there. If you pull the block by x down, find the compression in the spring. You're goofing up. Is y 2x cos theta sin theta? No, Utsav, that's not right. You're doing a mistake. I don't want you to find the relation between y and x. I want you to find the relation between change in y and change in x. If I pull this by x down additional, what is the displacement and the or change in the horizontal distance displacement? Two, no, Arjun, that's not the answer. See, forget about the spring for some time. So if you take this thing as y, if you take this thing as x, this is theta, this is theta, this is L, this is 90. From here you can clearly see x is equal to basically this length here. That is how much? L cos theta. This is L sin theta. So we get y is equal to 2L sin theta and x is equal to 2L cos theta. So from here, if I do dy, that would be 2L cos theta d theta. If I do dx, minus 2L sin theta d theta. So if I divide them, I end up with dy is minus dx cot theta. The meaning of this is, if you pull the spring by x downward, the horizontal compression will be dx cot theta. So this is what it means. If you pull this by x downward, this guy will compress by dy, which is dx cot theta. And the negative indicates compression. The horizontal displacement, or you can say spring compresses by dx cos theta. Like I said, you're not interested in the relation between x and y. You're interested in the relation between change in x and change in y. Spring compresses by x cot theta. Negative implies decrease. Clear with this? So there. So every time you pull the block by x, the compression in the spring is kx cos x cot theta. अभी क्या करना है? Now try. I'll give you a minute. Try from here. So this is the first thing. So whenever you displace something, doesn't mean every time the spring will displace by x. I know I have taken y and x in the reverse, but I hope that is fine. Anyone not convinced with this part, please ask me. Like I said, when you displace by x downward, the dx, I want to find the change in dy. Now what to do? Try. Think. I'll give you a minute. Now it's just a matter of FBD. Just give it a try. I'll just get some water and come. Any answers? 2 pi root x1 plus cot theta. God. In time period, why the hell will you get x? Think about it. Time period में, why will it depend on how much you pulled it down? अभी तक कोई भी problem में, did you ever get the time period in terms of amplitude? Then, so your answer says if I pull it more, I'll get more time period. But string block systems don't work like that. See, you start with an FBD. So you pulled this by x, the spring got compressed by x cot theta. So at this point here, if you look at the forces, tension, the spring is pushing with kx cot theta. And this angle here is 90 minus theta and 90 minus theta. And this point here is massless. Therefore, 2t cos 90 minus theta is kx cot theta. So we get tension in the rod is kx cot theta by 2 sine theta. Now, at this bottommost point, the rods are massless, rigid, light body, so there will be the same tension, right? And we have a block here, M. Again, this is theta, this is theta. Remember, what is T here? T is not the total tension. Here, T is the change in tension, the additional change in tension. Because, tell me one thing, isn't the spring already compressed by some amount? Initially, do you think spring is in natural length? No, right? Spring already is compressed. So that will generate some tension. Like I said, we don't care about that. What we are interested is, due to the additional compression X, what is the additional change in tension? I hope you're making sense. T is the change in tension, X is the change in compression.
little bit faster.
अरे हेलो बोलो ना.
नहीं सर
What?
ठीक.
You figured it out. You getting it? Here, what we are writing is everything is changes. Initially, it is already compressed by something. This is the additional compression, this is the additional tension. That's why we won't write mg here. So the restoring force is 2t cos theta is equal to mass into acceleration with a minus sign because we're taking it as down. 2, this will be kx cot theta by 2 sine theta cos theta is minus ma. A is equal to minus k cot square theta by m into x. That's your omega square. So time period is 2 pi root over m by k cot square theta. You can push it up and make it tan square theta. That's your answer. Check. Your answer will never depend on x. It should not depend on x. That is the whole point of SHM. If the time period starts depending on the amplitude, it is not SHM. Please check it out. So there are two parts to the problem. The first part of the problem is figuring out if I pull the block by what amount the spring is compressing. The second part is writing two FBDs, one on the horizontal and vertical, and getting the tensions. Check. Ask me if anyone is not convinced with this. Clear? Can I go ahead? Next one. So I kept it in terms of theta, meaning normally I can give you some angle theta 60 degrees or something. You just need to put it there and you get the answer much faster. Clear, na Arjun? Ali?
Yes, sir.
Palaksh, Neil, clear? Won't it be mg? God, why na? You don't write mg. Mg does not change. Remember, these are change in forces. We are not writing the net force. If you're writing net force, क्या होगा पता है? This will be T plus dt na. So what I'm doing, I'm directly writing dt only. The old tension plus the change in tension. So that T's will cancel the mg. Okay. All got this? Clear na, Anika? Anusha, got this? Malika? Shasha, got this? Perfect. Next one. Let's make it vertical. Let's do a smaller, easy one, then we will do this directly. It will be too much.
Sorry, I have a doubt in the last one.
No.
Like the compression, can we find it using work energy theorem?
Compression, you want to use work energy theorem. So show me, na.
Okay, I'll try in the break.
That's what you should do. Na. You should try and then you should ask. You shouldn't be, throwing your doubts onto me. You think there's an idea, you should try, get something. And if you're getting an answer, then you're on to something. Then we discuss. That's how it works.
Okay.
If you start saying like that, what will happen? Can I somehow use Lensmaker formula and try to find the change in length? Why can't I think about it, right? Matlab, hey yoga, you'll start throwing it onto the teacher. So it's your idea. So work on that. Come up with a plan. That's important. Not only now, remember this, tomorrow when you get a job or a startup now, if you have a plan, work on that, document it properly, mail it to your senior and others also. Because to jacket सिर्फ idea बोल दोगे, Someone will think it's a good idea, they will copy that and they will present it as their idea. And then you'll go out and say, "Arey, ye to mera idea, ye to copy kar liya." I'll teach you in surface tension. When I was in 11th, I had an incredible idea. I thought I'll be the world's richest man. The entire plan was flopped. I was supposed to become the world's biggest energy producer using surface tension. But my physics teacher has smashed the whole plan. Get this, fine time period. Pulleys are massless and smooth. I'll show you multiple springs are there, what to do. But before that, let's do it one normally, then I'll give you a shortcut. How to do? First was easy. See, you go back to the standard process. What's the standard process? Displace it by x. If I pull this by x, the spring also will go by x. So if you look at the forces here, this will be tension, this will be kx. Remember, all these are change in forces. Already spring mein some elongation is there. Already string mein there is some tension is there. So this is the extra tension T which you got because of the additional elongation x. So on the block, you will get this tension T, same string, and acceleration down. We don't write mg because it doesn't change. T is equal to minus ma. T is nothing but kx. A is equal to minus k by mx. Time period is 2 pi root over m by k. Here, if I push this by x, let this thing go by y. Now, look at this thing here. If the pulley goes down by y, how much will the block go down? Look at this part here. Whenever this thing goes down, you will lose y string here and you will lose y string here, na? So ye jayega 2y, isn't it? Is that making sense? That means whenever you pull the block by x, the spring will elongate only x by 2. Hope you got that thing. Pulleys always work like that, na? Whenever you give the pulley some x string, it will distribute x by 2 on both the sides. That means on this FBD, this force will be ky, this will be tension, and this will be tension. So 2t is ky, but y is x by 2, so that is kx by 2. So tension is kx by 4. So on the block, the force will be tension and acceleration. Again, we are not writing mg because m is not changing. T is equal to minus ma. We get kx by 4 is minus ma. So A is equal to minus K by 4m into X. Time period is root over 4m by K. So there are two things happening here. When you pulled the block by X, the spring only got half the elongation. And that half the elongation again became half because there are two tensions. Check it out. This is how you solve the problem normally. ये फिर भी ठीक है, one spring तक. But once I have 3-4 springs, it becomes a big mess. Then let's see how to handle that. But please have a look at this. Clear? Anyone not clear with this? Malika, Swastika, Rehan, got this? Udyan, clear, no? Palaksh, Aditya, Adrit, Vartika, clear with this? Next one. Now, let's take a thing. This is an important one. You can mug up the result. We have done something similar. Equivalent spring. So if you have multiple springs, T square by K equivalent is T1 square by K1, T2 square by K2, so on till Tn square by Kn. So where Tn is the tension in the nth spring. This T is the tension in the block. So whichever block you're considering, uska tension. The only problem with this method, it works only for single block. Valid for one block and smooth and massless pulleys. You can have 100 springs, but you should have only one block. Do you guys remember NLM में हमने कुछ किया था ऐसा? There was a big formula like that, tension equivalent. So let me show you an example how this works. So the same problem which we did right now. So let this be tension T. If this is T, the tension here is 2T. So the formula here is T square by K equivalent. That spring will be 2T whole square by K. So we get 1 by K equivalent is 4 by K. And we know time period is 2 pi root over m by K equivalent. 2 pi root over 4m by K. Easy? कुछ confusion नहीं. X by 2, that, this, everything is taken care of. Let me give you one more. We have a spring here, we have a pulley here, we have a spring here, double springs. Let's say this is K1 and this is K2. Find the time period. Find the time period. Get them all. Find the K equivalent and your job's done. If you try to do this normally, you would still get it, but it becomes quite complex. Let the block go by X. Let this spring go by X1. Let the other spring go by X2. Then we need to find forces and all that stuff. This saves you a lot of time. Only drawback, you can do it for one block. If you have two blocks, even normal method is also a big mess. K1 plus 4 K2 by K1 K2. Yeah. I have something to ask. Listen. If this question comes in the exam, and for some reason you forgot the formula, how do you guess this? If this question, first one, comes in the exam and you forgot the formula, and guess karna hai, how will you guess this? Anyone? Take 30 seconds. Think. Everyone focus. How do you guess this? You can solve. I'll give you time. How do you guess this if you forgot the formula and if you see this question and you have to guess? What should we do? Any ideas? Springs are in series? Seriously? When do you say two springs are in series? Be careful, huh? Don't say anything. Because what will happen, you will go and do the same thing in the exam. Here, I am there to scold you and correct you. Exam, there will be no one there. Exam will simply give you a -1. When you're speaking, remember, your consciousness remembers that. Conservation energy. कैसा करेंगे energy conservation? I mean, you're not wrong, but उससे क्या होगा? It's like saying I'll use prism formula, which is mu is equal to sine A plus delta by 2 by 2. Formula is right. But what the hell that has to do to this problem? K2 ka coefficient should be K1. See, how will I guess? If I put K1 is infinity, what does that mean? Whenever you guess, you always change the question. If I put K1 infinity, what does it mean? The spring will never stretch, right? It's become a rod, isn't it? If I put K1 infinity, shouldn't this become like this first problem? So the answer should be 2 pi root over m by K2, isn't it? So in all the options, put K1 is infinity, and whichever option gives you answer 2 pi root over m by K2 might be right. Is that making sense? What is the meaning of K infinity? The spring will never stretch, means it's a rigid rod. You can play with springs like that by putting as infinity. When you put K infinity, you're making the spring into a rod. Now try to solve. Get it? Yeah, first is right. Just find the K equivalent, na? We can then simply write 2 pi this thing. What is the first one ka time period? So start like this. This guy is tension T, this guy is also tension T, and this guy ka tension is 2T. So T square by K equivalent is 2T whole square by K1 plus T square by K2. So 1 by K equivalent is 4 by K1 plus 1 by K2. If you take this tension as T, this is T by 2, this is T by 4. So T square by K equivalent is T by 2 whole square by K plus T by 4 whole square by K. So 1 by K equivalent is 1 by 4K plus 1 by 16K. समझ में आया? And from here we can find time period as 2 pi root over m by k equivalent. Get the third one also. Try. I'll give 30 seconds. That's it. Start with the tension in the block T and find the tension of remaining all strings using whatever it is, forces and stuff. And then put it in the formula. All you're interested is the coefficient of tension. Saves you a lot of time, these things. Whenever you have multiple springs with a single block. So I should have made the diagram little big now. This is T. This guy is 2T. So T and T, this guy is also 2T. This guy is also 2T. This guy is also T. Hope that was fine. So T square by K equivalent will be 2T whole square by K plus 2T whole square by 2K plus 2T whole square by 2K plus T square by K. It's all this, you'll get the answer. K by 9K. Easy. Clear. Now this thing they can play like this also. I kept a block like this. K, K, to make our life simple little, I'll make all Ks. This is the block of mass M. So the question is, initially system is at rest. So the question is, now someone is applying a force F. When force F is applied, it will start oscillating. Find the time period and the amplitude.
So it means it is just displaced by x, right?
Hmm. Adrit?
Does it mean that it's just displaced by x and I have to find that normal function?
No, it is not displaced by x. देखो initially rest में है. You applied force. So with the moment you apply the force, what is the initial velocity?
0.
0. मतलब ये extreme position था ना? So this block will go till where? Mean position. Mean position में क्या होगा? Force is 0. But the block is having maximum speed. It won't stop. It will continue going further. Then again वापस आएगा. So this block system will continuously keep going front and back. तो यहाँ पे कहीं पे mean position आएगा. So I'm asking you to find this guy ना amplitude. So I'm asking you like this: find the elongation in the spring, or find the distance moved by the block in equilibrium. That would be a proper, that's a question in NLM. If the force F is applied and the system is in equilibrium, find the displacement of the block from initial position. Is that clear, Adrit, what I'm asking? Adrit, clear with the question? Yeah. Anyone didn't understand the question, please ask me. Question is clear, go ahead. Think for a minute, then I'll give you a hint, and then I'll give one more minute. Multiple springs is a mess, but that formula will save you. Because देखो ना, just to give an idea here, if I say this thing is going by y forward, this will go x1, this will go x2, this will go x3, this will go x4. Literally every spring will stretch different amounts, and I have no idea what the hell it is. तभी एक spring को elongation सब we have to figure it out. We can do that normally. It takes a hell lot of time. And Anika, you're saying energy conservation. You know how we get this actually? Iska proof is actually conservation of energy. I'll show you the proof. See, listen, it's not important, but I'll just give a little idea. What is the spring energy stored? Half kx square. I can write this thing as multiply and divide by k. Kx whole square by 2k. So this is the tension, no? Make sense? Now, when I pull this by F, the work done will be tension square by K equivalent 2 times. This is since you're trying to replace the whole thing with one spring K equivalent, whose tension is T. So the total energy stored in this one spring, T square by K equivalent, should be equal to the energy stored in all the other springs. T1 square by 2, 1, T2 square by 2K2, and so on. 2 cancel ho jayega. Is that making sense? When I pull the block, the energy stored in the equivalent spring should be equal to the energy stored in all the springs. So from there you get it. Amplitude is 18F by 25K. Okay. So first thing, find the K equivalent of this. Start from there. Find the K equivalent. If you find K equivalent, your job is over. You can make the whole thing into one spring and one block and one force. बस question खत्म हो जाएगा. Find K equivalent. Yeah, 13M by 16K, 13F. Someone got 18F by 25K. 13M, 18M by 25. Okay. Try. I'll give you a minute, then I'll show you. Find the K equivalent. Let's start here. Let this tension be T. If that is T, this guy will be T by 2. This guy will be T by 2. This guy will be T. This guy will be T by 2. Now, if that is T by 2, this is also T by 2, and this is also T by 2. This will be 3T by 2. Because there are 3 strings now. Please check whether you got the tensions right. Now here, there's a thing. Be careful. What is the total tension acting on the block? T plus 3T by 2, isn't it? So the total tension acting on the block is T plus 3T by 2 square by K equivalent. Then tension T square by K, T by 2 whole square by K, T square by K plus 3T by 2 whole square by K. I hope you have taken the total tension. और flow में सिर्फ T ले लिया. The T is the total tension acting on the block, isn't it? The total tension is 5T by 2. Now simplify this. T cancel हो जाएगा. That guy would be 25 by 4 K equivalent 1 by K 1 by 4K 1 by K plus 9 by 4K. To solve this, you'll get K equivalent from here. I will leave that to you. I trust your max. So the question has become like simply you have one spring, which is K equivalent connected to a block of mass M, and you're applying force F. This is your mean position, initially velocity 0, or you can also say this is your extreme. The block will go ahead somewhere till here. This is your mean position. This should be equal to force F, and this should be equal to K equivalent into X. That's your amplitude basically. So X is equal to F by K equivalent. The distance between extreme and mean is your amplitude. And what's the time period? 2 pi root over M by K equivalent. I think the mistake you might have done is this guy. Second mistake you could have done is this guy. Tension is 3T by 2. Check. That is generally, those are the two places where you can goof up a bit. Especially this part. Because you have a habit now. What is T? Tension. Tension. What tension? Tension on the block. But each block there are two tensions. So what should you take? Total tension on the block. Because the block will think the total force that is pulling is 5T by 2. Is this making sense? Have a look at this. Take a break. Come back by 7 o'clock. Any doubts, anything so far, anything you're not clear, please ask. Is this fine? This is a good one. I know maybe the calculations are a little complex, but क्या है उत्साह 64 by 37 क्या? Did the same thing? No, you did something else.
No, I would 3T by 2 is right or something.
By any chance anyone got this? So no props. Find it out. This much you can add. I trust you guys. Chalo, take a break then. Come back by 7. 25 के भी 18 आ रहा है क्या? ठीक है. Chalo, I'll be back by 7. Yeah, comes on everyone. So far we have done spring and block systems. Now every time they won't keep giving you spring block, spring block, spring block. That's boring also. So they can ask you some other deadly stuff. Let's say. Like I said, like SHM, right, is simply a cherry on the cake. The entire question belongs to some other chapter. In the end, it will come and hijack it and say, this is SHM, this is SHM. देखो हर क्वेश्चन ऐसा ही था. You're finding a is equal to minus some x square and you say, oh, this is omega square, this is SHM. This is like your friend in the lab, you know, who comes and sits every day. After completing the project, she takes credit for it. That way. You have a friend like that? Once you go to engineering, you will find. No. So when we were in IIT, we used to be 5 people in our group. Roll number 1 to 5 and roll number 6 to 10. So sub alphabetical order hai na. So roll number used to be like, you know, my roll number 5 to this thing. So my group ka team na, I was there, Arun. There is Arun Sahu. There is Arundhati. There was so A khatam tha wahi pe. Arundhati is like, she's so she used to come from Assam. She used to take 3 days in train that time. And there is another girl called Bal Mogambika. She was a proper Tamilian. Name used to start with B. So next alphabet tha. And there is one more guy re. यार उसका नाम भूल रहा हूँ, but I used to call him Poison. कुछ तो था. This guy was a big RG guy. मतलब he's like, अरे मैं कुछ भी नहीं कर रहा हूँ करके he does everything. Kidding. So we 5 people used to be there, na? So basically it was I think group of 6 or something. So basically 2 girls and we 3 boys used to be there. Now Arundhati is fine. Bala Mogambika, right? She is something, huh? Matlab we think she's cursed. So what used to happen now? I still remember one day, I and this others Arun, right, Sahu, we both are going in, kuch electrical lab tha, we are setting up the whole system. So we have to generate the power, we have to run the engine, something kuch to chal raha tha. Arundhati was just sitting there and handing over everything, right? Kuch to hua, I went away from there. I came after 10-15 minutes and Poison was shouting on Bal Mogambika. Why the hell did you come here? Who told you to come here? Get out from here, go there. I said, yaar, to kyun chilla rahe ho? Chill out, na. Why are you shouting? Like, what happened? You don't know, Arun. The moment she comes, the machine stops working. I said, yaar, what the hell are you talking, Ray? Like, ये machine वो क्या करेगा? उसका क्या mistake है? I said, you see, you will understand करके. So he got pissed off and he went. He went away and this Bal Mogambika was almost in tears. I said, yaar, Bala, tu idhar aa. Tension mat like he keeps like that. वो tension में छोड़ दो उसको. This guy went away somewhere. So this girl came. So we 4 are there. We again assembled everything अच्छे से. We निकाला. We kept there. System was not working. Then I said, "Arey Sahu, check karna, kuch to gadbad hai, something that this is." We checked everything; it was not working. Then, for some reason, right, this girl went away to some other team ka thing. Right, she went. We started. System started working, and we are like, okay. And the best part, the moment she went there, their system stopped working. Like कुछ तो हो रहा है मतलब then this Poison guy came and said मैंने बोला था I told you guys there is some problem with her the moment she comes it doesn't work. अरे यार from that project onwards ना so every time we start the project कुछ तो electrical lab था we used to call Bal Mogambika and we used to say बाला वहीं पे जाकर खेलो ना we used to give her something to play we used to send her off right we used to call the instructor when he used to come na we used to start immediately we used to show him because instructor का problem he used to ask बाला को बुलाओ all 5 should be there. We used to tell him, sir, if she comes, it doesn't work. He used to look at us so weirdly, it was true, you know, it happened 3 times when I was there. So finally, even I had to believe something was wrong with it. So I had a feeling like maybe whenever she's there, she removes something. We have to be a little scientific, na? Itna curse kaun believe karega? But the best part is whenever she used to go to the other team, even they used to get scared. So finally, she joined in some big finance company. That was the last time we heard about it. I hope the company is still on, but
The company stopped working.
yeah, पता नहीं क्या पता company is there or not. So every time you won't get a spring and block. So and luckily or fortunately after that we never got to team up with her again. That poison guy was so pissed off on her because उसको लगता था because of that girl his grades will go down. He used to go pissed off. So we have a big tank here. We have a cube here. Side L. I gave you this as an example, right?
Yes, sir.
We did. We did that as an example. Perfect. The cube, let's say base area is A. This container ka base area is 2A. Density of the block is rho B, density of the liquid is rho L. And rho B is less than rho L, so it is floating. So find the time period for small oscillations. So if you push the block by X and release it, find the time period for small oscillations. We're almost done with the linear SHM part. So people who want to do now, they can do first 31 questions in HCV. Start doing it. Don't wait for the chapter to get over. HCV question 1 to 10. साइड चाहिए क्या? ले लो साइड चाहिए तो साइड एल. What happened? Two pi rho B L. Now, Utsa, in this, did you take care of the base area 2A? Did you use it anywhere?
फिर इसका काम है क्या? I don't get it.
Yeah, that is a trap.
सर अगर इसका काम होता तो दूसरे क्वेश्चन पिछले वाले में क्यों नहीं यूज होगा?
See, that's the same way I always felt about Bala. When she is there, why it doesn't work? You have to find the reason now. I was quite sympathetic that poor girl actually. I always used to feel bad, like यार उसके साथ क्या हो रहा है? That poison guy was really weird. मतलब उसका अलग ही था. That guy applied for 125 universities for internship in Europe. वो literally professors को harass किया था यूरोप में. मैं मद्रास में मैं वो था, मैं ये हूँ, IIT मद्रास में I'm the top student. That this कुछ भी लिख के ना. Finally, some professor got impressed and called him for internship also. वो best part है. And he did for almost 2 years का effort था वो. For that, though, we have to, praise him. Consistent harassment to European universities. इस तरह करके finally he is also into finance. They pay you good, रे. क्या करेंगे? And the payment is good. What is the catch here? This is the catch, उत्सा. इसका area A और इसका area 2A. The moment you push this, water level भी बढ़ेगा. In that previous question, we never cared. Because the water level was so big, we ignored it actually. We took the base area as small. So see, this is what it is happening there. Initially, this is the water level. Now, when you push it by x inside, when you push it by x inside, it is not x anymore. This part will go inside because you pushed it. What is the water displaced? You'll get, now when you push this water displaced here in the container, do one thing, forget about this container, just take this cavity here. So when you pushed it inside by x inside, the overall liquid here also will rise now. Let this rise by y. Making sense? How much will that increase? For simplicity, I will take this as base x1, a1, and let's say iska area is a2. So what is the volume displaced? This guy will be a1 into x. What will be the area of this green one? If you see the top view now, green one will look like this. This area is a1. This green, this shaded area will be a2 minus a1. Do you agree? So if I push the block by x inside, the liquid displaced is a1x. So the green liquid will rise up by how much? a2 minus a1 into y. So y will be a1 x by a2 minus a1. That means whenever you push the block, in reality, you think you pushed it by x inside. So initially when the block is like this, when you try to push this by x inside, something else happened. The liquid level also came up, because of which your block has gone x inside, and that additional liquid has gone up by y. Is that making sense? So what is that additional bind force? So the extra bind force is density of the liquid into x plus y L square into G. Is that making sense, everyone? If you push the block inside by x, the liquid level also will go up by y. So what is the total extra depth the liquid is inside? X plus y. So the restoring force here will be delta FB is minus mass into acceleration. So this will be rho liquid L square G x plus y will be x plus A1 x by A2 minus A1 is equal to minus mass is rho B L cube into acceleration. We'll get A is equal to minus omega square x. So get omega from there. Time period is 2 pi by omega. I hope this was understood. I did everything in terms of A1, A2. You can substitute the values. Is that making sense? Arjun? Arjun?
Everywhere the second part was negligible, right? That's why we ignored it.
कहाँ पे? यहाँ पे हाँ, जो एग्जाम्पल दिया था मैंने, I ignored y there. So
हाँ,
in this question
okay.
ना, we took the base area to be large. कुछ mention नहीं किया.
Understand.
Simple thing. If the base area is not mentioned, I can't solve. So I will assume the area is very small, negligible, the content, this block. Are you getting the difference between 14th and that? So the biggest hint in the question is that base area is given. Please have a look at this. It's a good one. So यहाँ पे, I think here you'll get x is equal to y, isn't it? So when you push the block by x, it actually goes 2x inside. Because here a2 is 2a. Is this understood? Anyone not convinced, please ask. This is a very good one. I am little worried, maybe you're confused. Please check. Neil, clear with this? Maulika, Swastika? Clear, na? Got that idea, na? Why the water level is not going x, but it is more than x plus y? All sure? Let's see one more. This is fluid mechanics and SSM. There we have a pipe like this. This is theta 1. This is theta 2. You have liquid exactly till here. This is length L. This is also length L. This is also length L. I hope everyone understood why I took A2 minus A1 and not A2 into Y. Because the block which is occupying that A1, that area is not included. Clear now, Aryan? So now the liquid is displaced. Find time period for small oscillations. And just to give an idea, if I push this liquid by X down, this liquid here will rise now. So the whole system will start oscillating up and down. How do we do this? One side is theta 1, one side is theta 2. I took uniform cross section. I can mess up the areas also. That will be even more deadly, but let's not do that right now. Anyone didn't understand the diagram, please ask. Liquid ka density, take it as rho p, rho le. So you push the liquid from one side. So this will start oscillating because of imbalance. Think. It's a good one. The simple version in the problem is this. Just take a U-shaped one. That's an easy one. Or standard, matlab that you can handle it. This is more deadly. If I make theta 1 is equal to theta 2 is equal to 90, you will get that case only. Should I help you with the little thing? See, if I push this by X, ये ऊपर कितना जाएगा? This will go by X, agreed? Now, what is the difference actually? So the liquid will be this liquid till here. That means the difference is, till here there is no problem. The problem is this guy, na? Do you agree? That is that additional liquid which is pushing the whole thing down. Do you guys agree? Now this additional liquid का force कितना होगा? This part का force will be rho area x g और ये cross section का part कितना होगा? Rho a sin theta x g. Is that making sense? So what is the total restoring force? Rho a x g plus rho a sin theta x g is equal to mass into acceleration. Clear? Did you get the idea what is happening? The restoring force will be two components. One, the vertical component and the slanting component. Both are pushing the whole liquid down. Because of that, you're getting a net acceleration. I hope that gave you a little hint. Try, I'll give you a minute. So when you push the liquid by X on the one side, you actually go 2X on the other side. Think like this. Let's say in my gang, there are 10 people. In your gang, there are 10 people. I buy 2 members of your gang. What is the difference between your gang and my gang? 10, 10. If I take 2 people from your gang, you become 8, I become 12. Cap is 4. It is not 2. I gained 2, you lost 2. So difference हो जाएगा 4. So when I push one side by x, the actual displacement is 2x on the other side. Think. Why people are so tired today? Holi ka effect? No. Too much Holi and people got exhausted. There is one guy in our class today. He still has pink color. He looks like an alien. So let's hope the color goes off. I don't know what kind of toxic colors he used. So today we are calling him mutant. Okay, very organic. Should I show you? See, first thing, when you push this side by x, the liquid here rises by x. So the diagram actually becomes like this. This is how the diagram will look. The liquid is from here only. So the restoring force will be what did I do? So F restoring will be due to 2 parts. This weight, which is rho area x g, this slanting guy rho area x g sine theta. So F restoring will be rho a x g 1 plus sine theta 1. This is equal to mass into acceleration. What is the mass? 3 rho, length is 3L, area into acceleration. This will give you rho a xt 1 plus sine theta 1. So we get acceleration is equal to rho will cancel, a will cancel. This guy will be g by L 1 plus sine theta 1 into x is minus. So this will give you time period t1, which is 2 pi root over 3L by g into 1 plus sine theta 1. This is not the answer. Which vertical component you're talking about? Array, the force is the reason you're moving is because of this force, na? This will be cancelled by the normal reaction. हाँ Adrat? Cos theta will cancel by mg. अभी देखो problem ये था, this same thing I have to do it in the reverse now. The problem in this thing is when you go to the left hand side, the angle has changed. Now, if you push this side by x, the liquid will be like this. This will be x. The restoring force will be, this will be rho a xg. This restoring force will be rho a xg sine theta 2. समझ में आ रहा है difference? The restoring force is not same on both the sides. So if you take this guy, this acceleration will be rho a xg 1 plus sine theta 2 is equal to minus m into acceleration. So this time period would have been t2 which is 2 pi root over 3L by G 1 plus sine theta 1. So when you're on the right hand side, the restoring force is 1 plus sine theta 1. When you're on the left hand side, the time period is 1 plus sine theta 2. So the total time period will be half of each now. See now, when you're on this side, only this is the restoring force. When you're on the left hand side, this is the restoring force. So these are actually two SHMs, T1 plus T2 by 2. That's your answer. I will leave it there. The restoring forces are different, so the time periods are different. You know, how is this question like kind of? This question is like this guy. This problem, the elastic thread wala problem. When you're on the left hand side, only K1 will act. When on the right side, only K2 will act. You take half of each oscillation, isn't it? If you look at here, it's the same thing here. When you're on the right hand side, this liquid is only not there. When you're on the left hand side, this liquid is not there. So you get half of each time period. Please have a look at this. The standard question in this, in the books which you'll find, is this guy. Everything is straight. That will make your life much easier, actually. Here I messed up both the sides, the angles also. Check it out. Any doubts on this? Anyone not convinced with anything particular? Next one. Anika, Partika, clear with this? Everyone should definitely try all the problems we did today. So most of them are quite weird. They're not difficult, but if you don't practice them, you'll forget in 2-3 days. After a week, you'll feel like I have seen this somewhere. It looks like your long lost school ka friend. You know you have seen them somewhere, but you just don't know who are those. Like, where did you see them? What is their name? Next one. So that is fluid mechanics and SHM. Next is your all favorite. We have a piston, completely insulated. On one side, we have helium gas. On one side, we have hydrogen gas. Pressure is P naught, volume V naught, temperature T naught, pressure P naught, V naught, T naught. So this is a piston of mass M. It is smooth. There's no friction there, and insulated. Area of cross section is A. So initially both the sides the pressure are equal, system is happily at rest, everything is good, then you go and mess it up. So you disturb the piston slightly, it will start oscillating. Find time period for small oscillations. The word small oscillations is important. You don't displace it too much, then it will become oscillatory motion. Find time period for small oscillations. Thermodynamics and SHM. Meaning, just to give a little context, if you push it to the right, what will happen? Won't this pressure increase? Won't this pressure decrease? So that means the pressure is pushing the piston back. So this will start oscillating in the middle. Get this. That's what I said. Question is some other chapter. This guy will come and take credit. Let's see how will you guys do this. Find the time period for small oscillations. It looks scary and deadly, but you can actually handle this. Try. Anyone not clear with the question, please ask me. Anyone not convinced with the question? I'll give you a little help. If you push it to the right side, what kind of process are the gases undergoing? Adiabatic compression, isn't it? If you push it to the right, so start like that. Let the piston move by x to the right side. So right gas will have adiabatic expansion, left gas will have adiabatic expansion. In adiabatic process, what is the relation? PV per gamma is constant. Start from there. So that is how the theme is always. When you displace something, there will be an unbalance of forces. You messed up the forces. That unbalance will try to restore it. So you need to think how the forces changed. Try. 2 minutes. It's a pretty good one. Advanced level, mate, it will be a good single choice question. Okay. Saying someone feels little like sir, thoda easy ho gaya. You can put a string also here. You can play around. But okay. You got the idea. That's right. Show you. What is gamma for diatomic? Someone understood the whole question. Someone knows everything, but they don't know gamma for diatomic gas. What to do with you? Huh? Ever seen this thing? Hero is there fighting with 100 villains. They bring guns, weapons, everything. He kills everyone. End में, right? The heroine comes and takes a knife and pokes him and he dies. मतलब क्या है story मतलब? Gamma is 1 plus 2 by f, right? God. Forgot. Drunkards. Don't forget standard results. See, this is how we do. So let's displace this by x. So when you displace this by x, this side the pressure becomes, we'll just push this guy here. This pressure becomes, let's say, P plus dP1. This guy becomes P plus dP2. Again, always assume it is increasing. Mathematically, we always assume the functions are increasing. The science will take care of it. I know, left side of the pressure decrease hona chahiye. Don't get into that. Assume it is dP2. Now, on this piston there, if you look at the forces, the additional force is dP1 into area. This guy is dP2 into area. And this is your acceleration. So we have dP2 minus dP1 into area is mass into acceleration. So far clear? And we know for adiabatic process, PV per gamma is constant. Differentiate on both sides. Now see, I'm not interested in pressure. I'm interested in change in pressure. So this guy will be dP V power gamma plus gamma P gamma V power gamma minus 1 dV. You know where we have done this? The graphs of isothermal and adiabatic graphs में मैंने differentiate किया था, same thing. So from here you end up with dP is equal to gamma P naught by V naught dV with a minus sign. Clear? That's your dP का relation there. So if you take dP2, this will be minus gamma P naught by V naught. This will be A into X. Actually, the pressure decreased. You see, you got a minus sign. That's what I'm saying. Signs will signs take care of it. dP will be minus gamma P naught by V naught. ये होगा gamma 2, ये होगा gamma 1. Gamma will change. This will be minus A into X because the volume changed. So this guy is actually plus. So if you substitute these things here, you end up with minus gamma 2 plus gamma 1 P naught A X by V naught is equal to mass into acceleration. Therefore, acceleration is minus gamma 1, and gamma ka value, 1 plus 2 by F. So I will leave it to you. You can substitute that. Gamma 2 P naught area by V naught into M is equal to X. Now our great SHM will come and say, CC, this is an SHM problem. This is omega square. Time period is 2 pi by omega. But what we did was everything was completely thermodynamics and FBD, loss of motion. SHM comes and takes the credit. Clear what we did? You can substitute gamma 1, gamma 2 values, P naught, area, everything there. Any doubts on this? That's a good one.
Take it separately from left side and right side, and then
So what do you mean by separately?
when first I discuss the left side, I got the left side force, and then I find half the time period, and then from right side.
Why have the time period here, God? But that means when you push it to the right side, this helium is not doing anything. Helium is not doing anything. Helium is also pushing now. This is not that question, where only one of them will act. Yeah, at any point of time, both the helium and both the hydrogen are pushing each other, isn't it? Clear with this, everyone? Let's see one more. Please check. Anyone not convinced with this, ask me. Next one. We have a table here with a small hole. We have a particle M going in a circle. This is attached to a block M. So basically, this is your table there. Gravity is there. This guy is at rest. This thing is going in a circle R. So this is going with some speed. This is a smooth table. So are you able to get this thing? The centrifugal force here is balancing the weight mg, na? So this guy is going in a circle. So that centrifugal force is generating tension, and that is balancing the mg there. So initially, the Kaplan is at rest. The ball M is rotating in a circle of radius r. The other end of the string is connected to a block through a hole. Everything is right. Right? To block M. Now, Someone pulled that block and displaced it. You pushed that block. Find time period for small oscillations. So someone caught this block, they pulled it little down and left it. Something happened. The whole system starts oscillating. Find time period for small oscillations. How do we do this?
So when they pulled it, the little mass was already rotating.
If I pull this by x, so ये भी थोड़ा, it will go down a little inside, na?
Okay.
It will go in a smaller circle. How do we do this? I think it's a proper good one again. First of all, see, try to understand, first try to accept the fact it will oscillate. Once you actually understood, okay, why it is oscillating, then forces will come into the picture. First, figure out why the hell this is oscillating. If I pull the block down by x, something happened and it pulled the block up again. What made the block go up? Who is pulling it up?
The radius of the circle in which the M is going is changing.
So
So
because the radius changed, something happened. Something happened that made force. So what is that? Complete the story. Centrifugal force increases. Abhi option to kuch hai hi nahi, because that is the only guy who can increase, right? Now how is it increasing? Figure it out. Anyone not clear with the question, please ask. Show you? You think it's decreasing? What is decreasing? Since radius decreases. Centrifugal force also decreases. The only guy who's supporting the weight is centrifugal force. And if that guy decreases, the whole thing will fall down. Listen to the catch. I'm sure you guys didn't think about what I'm going to say now. So when this guy is going here, what was happening was, this is generating tension. This was your centrifugal force. Let's call it m omega square r. And the other side, we have the block M here. So this tension is being balanced by this mg. So far, great. This is radius r here. Now, and if you look at here, so we get mg is equal to m omega square r. Now, the moment you pull it inside, the radius becomes r minus x. This is still going in a circle. Angular velocity will change. So now this will be, the centrifugal force will become m omega dash square r minus x. And this will be mg here, and this will be your acceleration. So the net restoring force will be mg minus mass m, the new omega, the new radius is equal to total mass into acceleration. The net restoring force is this. Now, why is this omega changing? Torque about the hole is zero since all the forces pass through. Therefore, angular momentum is conserved. So, initial angular momentum is equal to final angular momentum. So, what is initial angular momentum? I1 omega 1 is I2 omega 2. So, initially it is m r square omega m r minus x whole square omega dash. So, omega dash will be omega r square by r minus x whole square. This is what is happening. The moment you decrease the radius, omega dash is increased, which results in increase in centrifugal force, and that guy is pulling the system back again. The smaller the radius, faster it will go. Making sense? Because see, omega is changing as a square function. This is only power 1. Omega will dominate. Now can you try to solve? There, I gave you everything you need. So here, conservation of angular momentum will come. Rotational mechanics and SHM. So generally, right, when your seniors say, sir, we have only 2 hours and we want to revise something, the best chapter to do is SHM. You can bring every damn chapter into this. Ray optics, everything. Ray optics bhi aa sakta hai. Put a mirror and put a spring. The spring is oscillating. Image will start oscillating. You can bring electrostatics, magnetism, EMI, everything will come. Try. You got a minute. You have to use approximations, huh? X is very, very small. See? So we have mg minus m omega dash square r minus x is m plus ma. Omega dash will be omega square r power 4 by r minus x whole power 4. Because omega dash is omega r square tha wo. That will become r minus x whole cube. Take out r cube common. You'll end up with 1 minus x by r whole cube. Take it up. 1 minus x by r whole power minus 3. Binomial approximation. That is the reason x should be small. You end up with mg minus m omega square r minus 3 m omega square x These two guys will cancel. That was initially in equilibrium. Then A is equal to minus 3m omega square by m plus m into x. Omega ka value also is given here. So omega square is actually mg by small mr. Substitute that here. That is your x, omega square. That's your time period. Like I said, once you have done this part, right, question is over. Its physics part is over. It's just max after this. Since x is small, you can do a binomial approximation. If x is not small, it is an oscillatory motion, which we can't solve. Please check. Any doubts on this? Did everyone got the logic? The moment you brought the circle smaller, omega increased, the centrifugal force increased, the system will try to go up. If the radius increases more, omega will decrease, centrifugal force will decrease, mg will dominate, you will come down. So the system, right? If you look at the motion, this is how it looks. This block here, ball here is actually it's going like this. It's not going in a proper circle anymore. Because x is very, very small, you can ignore this. This is how the block is going. It is going in and out, no? It is going in a circle also, it is going in and out also. And during this process, this block is going up and down. This guy is oscillating up and down. Able to visualize how is it? The radius of the circle is continuously fluctuating. When it increases, mg dominates. When it decreases, centrifugal force dominates. So it just keeps going up and down. Please check the steps. Clear? Any doubts? Neil, got this? Aryan? Rehan? Malika? Clear, na? Vartika? Swastika? Got this? Vidyut? Yasha? Udyan? Aditya? Ali? Perfect. Can I go ahead? Last one for the day. We'll take a question from HCB. This is a question from HCB. I liked it. Let's do this. How to find there's no amplitude is initially whatever you pulled by x, that is amplitude. Because initially mean position pe hai na. So whatever displacement you give will become the amplitude. Right, Aditya? Read the question. We have two uniform plates of uniform plate of mass m stays horizontally symmetrical on two wheels rotating in opposite directions. Meaning this wheel is rotating like this wheel is rotating like this. You place the plate on top of it. If you displace the plate, it starts oscillating. Now you need to figure out why the hell it is oscillating and then find the time for that. Let's finish off. So SHM now will be a part of every chapter. Every chapter that comes, SHM will keep on adding up. Again, I'm telling you, forget about the answer, forget about the solving. Just think of one thing: why the hell is this oscillating? If you can figure out that, 50% of the problem is over. Then you'll get ideas how to solve. Always spend time on thinking what is happening. It might be a little irritating and might be time consuming, but the more you get used to it, the faster you'll get ideas. It is anti-clockwise, plate goes left. Nay, देखो ना, you're forgetting something here. They are rotating with constant omega. Plates omega is not changing. The wheels rotate with constant omega, if that's your confusion. Wheels omega is not different. See, oscillation कैसा है ना? You pushed it. You displaced it and left it and it started oscillating. It won't oscillate on its own. Initially, it is in equilibrium. When you displaced it, it started oscillating. Just to give an idea here, if this wheels, if this is rotating this way and this is rotating this way, can you tell me how will the friction be on the plate? So this point is going this way. This point is going this way. So friction will be which way for this? On the wheel, it will be F backward. On this thing, it will be forward. On the wheel, friction will be backward. On this thing, the friction will be forward. Make sense? There are two frictions on the plate. Do you agree? And also, you have two normal reactions on the plate. Now, if you displace the plate, what will happen? N1 and N2 will change. If N1 and N2 changes, F1, F2 will change. Think for a minute. This is what is happening. The moment you displace this by X, the center of mass mg will be here. This distance here will become L by 2 minus X. This distance here will become L by 2 plus X. This is N1 and this is N2. So we know N1 plus N2 is mg. And if you take torque about center of mass, that should be 0 because plate is horizontal. N1 into L by 2 plus X should be equal to N2 into L by 2 minus X. Because of this unevenness, the normal reactions will change. So whichever side you push, that normal will be more. If you have more normal, you'll have more friction. If you have more friction, you'll get pushed back again. So from here, I get N2 minus N1 L by 2 will be N2 plus N1 into X. So from here, I get N2 minus N1 is mg X by L. Now, if you look at this plate, this friction will be F2, this friction will be F1, this guy will be N1, and this guy will be N2. And this is the acceleration. So the restoring force here is F1 minus F2. So the frictions are fighting here. This is nothing but mu N1, mu N2 because it is slipping. But what is N1 minus N2? Minus 2 mg X by L. And then we get A is equal to minus 2 mu G by L into X. Therefore, the time period is 2 pi root over L by 2 mu G. Check. Rotational equilibrium. when it is exactly in the middle, N1 and N2 are equal. If N1 and N2 are equal, F1 is equal to F2. Both the frictions are cancelling out. There is no restoring force. System is in equilibrium. The moment you displace it to right side, the distance will become L by 2 minus X. Therefore, the normal reaction N2 will increase. If N2 increases, F2 will increase. If F2 increases, it will push the plate to the left. You're getting it? So it is going back to the mean position again. Now, if you go to the left-hand side, same thing will happen. F1 will increase. The plate will push to the right side. So the plate will just keep on oscillating left and right forever. So here there is being some energy losses there. So that energy is provided by someone externally who is maintaining the wheels ka constant omega. Have a look at this. Clear? It's a good one. It's not, I won't say it's a kind of a tough one, meaning you need to know what is happening. Once you understood that, it is easy to solve, but generally it doesn't click. That's why I thought it's a good problem from HCV. You can do 1 to 31 now. We have finished with linear SHM. Linear SHM is where things are only going in a line. The next part is angular SHM. So you saw even in SHM, we did two varieties here. One with spring and blocks, one with all different chapters things. The next part is angular SHM, that is more based on rotational mechanics. So you need to know your moment of inertia, parallax theorem, all that stuff. So we will do that in the next class, right? Most of it will be done. And then we have something called torsional pendulum. We will work on that also. I think mostly we should wrap up the chapter by next Wednesday. So do start solving. Don't keep it pending, right? We also have something called damped oscillations, which is removed from means, but advanced maybe be here. So again, we will do some part of it just in case. At least the basics, we'll finish it off and keep it ready. Okay, with that, we'll wrap up for the day, right? The test is online till Friday night, so make sure to give it complete heat and thermodynamics mains level paper. So any doubts, anything, stay back and ask, also free to